So our first scenario is fairly straightforward. It covers off on a pedestrian approaching a static vehicle. And there's a couple of variations to this particular scenario. There's one where we're approaching a vehicle that's in a safe state. And then there's a second one, which I'll take you through in a moment. But in the one that we're approaching in a safe state, it's probably important we talk about what safe state is first. Safe state is basically where that machine is safe to approach. It has to be defined by the operation, but typically you would have something like the park brake on, the engine in neutral, or maybe even in park, grounded tools, whatever it needs to be to feel that you're safe to approach that vehicle. So here we have a pedestrian approaching a safe vehicle, and there is a operator in the cab of that vehicle. That's really important to understand in this particular example. So as that pedestrian's approaching, let's just assume that the operator is unaware that there's a pedestrian there. So we get our A1 awareness on the screen, and if the operator doesn't look at that screen or is not aware of that pedestrian and takes the machine out of safe state, so puts it in gear or takes the park brake off, immediately we get that A3 alarm, that high level alarm to indicate that the operator, that there's a serious problem that needs to be addressed before any further activity occurs. So that's our first variation of a static vehicle. The second one is where the pedestrian approaches an unsafe vehicle. So this machine is prepared to move. And if that pedestrian continues to approach, so we get our multiple alarms. So we get our A1 to begin with, we get our A2, and if the pedestrian continues to approach, we get our A3. So there's various examples of where these two apply. Probably the big one, the easiest one to understand is go lines and around parking bays and workshops, where you have a lot of machines and humans interacting, particularly at the start and end of shifts or during crib breaks. You have a lot of that interaction, and you'll have a lot of different states of the machines. You'll have some machines parked up in that safe state, and you'll have others that are either trying to move or have just come in and haven't finished parking up. So it's a pretty important sort of scenario to understand. However, there are potential for false or failed alarms to occur. And in the next slide, we capture some examples of those false or failed alarms with pedestrians around those vehicles. So in the top left, a classic one that we've heard in the industry is the multiple pedestrians inside the vehicle. So they're sitting in the vehicle. However, the system thinks that one or more of those people are actually outside of the vehicle, and therefore it alarms and creates an alarm there. The next one across to the right of that one, we've got multiple passengers inside the vehicle, and we have a pedestrian immediately outside the door, possibly leaning in the window having a chat. And the system thinks that person, because they're so close, is actually inside the vehicle, and we have no alarm generated. So these are the examples of a false alarm or a failed alarm based on those sort of circumstances. And there's lots of real world examples of that. So if we go back to our go line example, if you look at the bottom left, we've got pedestrians moving around our vehicles. So they could be quite close, so they may not be detected. And this is a sort of classic example of what needs to be considered. The other quite important one, particularly in the underground space, is where we deliberately have activities that require pedestrians to be in close proximity to moving machines or machines that are active. A great example is an IT, or an integrated tool carrier as they're called, which is a tractor, an articulating tractor with a basket on the front. So you'll have someone in the cab of that tractor operating the vehicle, and then you'll have people in that basket. And sometimes in certain circumstances, depending on the job, you may actually have a person on the ground assisting, whether they're a spotter or they're managing another aspect of the job. But you do have people around a machine, and that's something that needs to be considered as part of the industry-wide design process. Another example is where we've got someone that could be under the machine. Sounds a little bit unusual, but there has actually been circumstances where someone has been under a machine. And we also have an example where a pedestrian could be invisible to the system by being inside of the articulation point. So being really close into the body of the machine. That, as anyone that's aware of loaders, that's actually where the main door is, the door access to get into the cab. So stepping inside of that articulation sometimes can possibly render you invisible to systems. So these are examples of a scenario that we know is a problem underground that we want to address with possible technology, but we're also aware that there are possible limitations or concerns around trying to address that. And this is what I was talking about, where we're trying to define the problem for the industry to ultimately try and solve, right? We want to work with the industry to try and solve this problem with our different suppliers. So this is what we're trying to define.